All right, let's continue on the topic of statistics. Moving on, in the last session or last episode, we were talking about central tendency and what does it mean. And then we discussed that out of the many ways, there are three most popular ways to measure central tendency, which is mean, median, and mode. And in this episode, we'll talk at length about mean. Maybe this episode and possibly the next episode, we'll talk about mean and understand with some of the examples on how to calculate the mean. Okay, so like I said, to understand the mean, we are going to take few examples, and there are typically two types of examples that come in. And again, some terminologies here and some jargons. The type one would be something called as ungrouped data, which we'll be looking at first, and then potentially in the next video, we'll be looking at something called as group data. So again, all these are jargons: ungrouped data, group data, raw data. So we just don't have to get overwhelmed when I explain it. It will be very simple, but as long as you remember which method to apply during the exams, that's all it matters. Okay, moving on. Let's talk about the type 1, which is mean of ungrouped data. And I'm going to take some of the same examples that I used in the previous video for central tendency, so that there is some continuity and we can relate back and forth when we cover more videos across the whole syllabus. Okay, so if you remember the first example that we took, it was an example of an individual student in someone diploma, and there were some 5 or 6 subjects, and we took his marks over here out of 70, the theory marks, and we also had a visual plot of how these marks kind of scattered. And the first question that we were asking is there a tendency for these marks, all these marks, to appear across a specific number or in a central region? And we knew that if you see this number 40, 45, 50, 55, there is most of the numbers kind of lie in this region over here. If you see, this is the 40 and this is a 50 range and this is a 60, right? So this particular range, the numbers kind of fall. So that's kind of the cluster, or the marks have a central tendency to kind of fall in this kind of area. And the whole purpose of mean, so we got this central tendency, and now we need to know what is a mean, in the sense that we do know that there is a cluster where the marks tend to be scattered around, but what is that exact one value or one measure which is kind of the centermost point, or which will define the central tendency? So what is the value of that? And that's what we are trying to calculate in this video. Okay, so the ballpark estimate we already have 40 to 45 marks, but what is that exact value? We don't want kind of a range, we want a specific value. And calculating that value using the first for the first measure is nothing but measuring central tendency using mean. And this is also called as arithmetic mean or average. And like I said, typically when we say average, we think that we're talking about mean, and that's what we are used to, which is okay. But all the central tendency measures, all of these are kind of averages. This is also one sort of average, this is also an average, and this is also kind of an average. But nevertheless, we'll keep moving on. Okay, so we're talking about mean, and let's try to see what it means. Okay, so when we talk about calculating mean, what it basically means is, okay, there's mean and mean, that's interesting. Okay, so it's typically denoted by x bar, x, and there's a bar on the top, or sometimes it's denoted by, I think, mu, like a U shape. Okay, and I'll get into the details of what is the difference between that. But for now, you can, for the syllabus point of view, you can just use x bar kind of a thing. And the formula for calculating the mean is you add up all the values in the data set. Again, data set is kind of a jargon here. What it means is the given set of numbers. So if you take this data set here, and if you take the marks, whatever we get here, whatever is given to us, the sequence of numbers or the set of numbers, that is called as data set. So don't get confused with the jargon. So whatever is the given values, data set, so we add all them up. We have maths, CS, drawing, graphics, mechanics, physics. So we add all of them, and we divide by the number of subjects. So if you see here subjects, we have it 1, 2, 3, 4, 5, and 6. So add this, whatever is the total, we divide by 6, and whatever value we get, that is nothing but mean. And I'll come to this concept of what is ungrouped data in a minute, hopefully towards the end of this video. Just hold on for that. But that's called as mean, okay, or arithmetic mean. And if you see here, that's all the formula says. Mean or average, which we can use synonymously, is add up all the values in the given data set or in the given set and divide by total number of values in the set. So which we know that it's 6. And this is also called as frequency. What is the frequency of that? Another jargon here. So frequency is nothing but the denominator portion or the number of values. And if you want to put in terms of variables, so we can put in terms of x bar, which is mean, is equal to add up all the values x1, x2, x3 all the way through x suffix n and divided by the number of values here. So if you see here, this is going to be your x1, this is going to be x2, this is going to be x3 and so on and so forth. And the number of values, this whole thing 6, this n in the denominator is going to be 6. That's what it means. So that's how we calculate. And there's another notation, the statistical form of notation, where we use this sigma for this particular portion, summation of all the values in the numerator. We use this Greek notation called as sigma. If you want to remember, you can remember. Otherwise, I don't think the formulas, how you represent, whether you use this formula or this formula, doesn't really matter, as long as you remember that sum up all the values in the numerator. There's a numerator, sum up all the values in the numerator, in the denominator total number of values, which is the frequency, and whatever is the value, that's your mean. And in simple words, for the example that we are talking about, what we are trying to do is we are going to add up all the marks in each subject, the numerator, and denominator is total number of subjects, okay, which is the small n is equal to 6, which is what we saw here. And these are all the marks here from maths to all the subjects, whatever we kind of calculated over here, x1, x2, x3, all these marks we are going to add up in the numerator, divide by 6, and in the green color you get this value 46.33 marks, because the unit is still marks in the numerator. So whatever is the unit in the numerator will get the marks. If it's marks, it's going to be marks. If we're talking about height of a person, then it's going to be in meters or centimeter. Whatever is the unit of the numerator kind of is retained in the final answer of the mean. So the mean and average of this individual, who is represented by this table or this graph for this marks for SEM and Diploma, it's 46.33 marks. Okay, so now we got the calculation. That's as simple as that. But what does it mean from a perspective? And I've again put that in a perspective just to logically close and cement this understanding in your head. So we had this marks for the student like a x1, x2 and x3. We got the total as 278. This was the numerator which we used here, right over here. Okay, so what does that mean is, okay, I'm going to use this mean and mean differently. So okay, so what does it mean from an arithmetic mean is, we have this different marks for this subject, and when we calculated this mean or average for 46.33, it is as good as saying that in general this student scored 46.33 in all the subjects. So if he had scored 46.33 in all the subjects, in that case also the total would have been the same. If you see here, it's 278 over here, and here it's 277.98, almost same. So that's as good as saying that, hey, I don't want to know the individual marks for the students. What is the average that he has scored? So we can say the average is 46.33, and that's how your typically mark sheet also kind of does. It calculates the average and gives you a percentage. So basically what it means is, on an average, this is how you scored on each subject. And if you see the visual here on this side, the orange bar, each of the orange bar is nothing but 46.33. So this whole line, the orange bar, is 46.33. So on a normal day, on individual subject, the score might be less or the score might be more. We don't care about that. But if you average out, this orange line remains constant. So we can say, hey, on an average, we got 46.33. And like I said, if he had got 46.33 in each subject, his total would have been still the same, and that's what it means. So instead of worrying about individual marks and trying to guess which is high, which is low, we're talking about the average. That's all it means. Over here, I've written that orange bar remains flat, as if the student scored the same marks in all the subjects. That's what it means. Okay, that's kind of the calculation of mean with an example that we took, and all you have to remember is this particular formula. Add up all the numerator and total number of subjects in the denominator. So let's see one more example, and then that should be a wrap up on this topic. So the second example also is in continuation from the previous episode, where we're talking about marks of a whole class. This time we are not talking about an individual, we are talking about a whole class, which is a bunch of 313 students, and we're talking about one subject. Okay, And what we have done is, over here if you see, 3 students out of the 313, so 3 out of 313 have scored a perfect score of 100. So instead of making 3 entries for this student, we are just combining this frequency so that the table will not become long. Otherwise we'll have to list 3. The way we have to do is, if you have to list everyone, we have to list, okay, one student got 100, there's another student who got 100, there's another student who got 100, and then we'll continue. So instead of having these 3 rows, what we have done is, since all of them have got the same marks, we cancel this out. We just put one row. We have 3 students and we have 100 marks here. So we are kind of grouping the frequency, okay? So just want to explain that. And there is a reason why I explained that, because although we are kind of grouping the frequency, I don't want you guys to get confused this grouping of frequency with the type 2 of the problem that we're going to discuss in the next video, where we're talking about group data. That is slightly different. So just keep that in mind. So in the exam, if this kind of problem comes where the frequency is grouped, don't kind of mistake it for the group data. So keep that separate. Anyway, so the reason we do this is we don't have to enter too many rows, so that it's very compact form of representation. And again, it was the same question saying that, like if you see here, I've just put the same thing that I've explained. Instead of listing every student, we are just combining or creating one entry for the students with the same marks. And this marks is nothing but the frequency. Again, jargon here. We have been using this in the previous example also, frequency. Okay. And what was the question here last time also? Is there a central tendency, or do we have a region when we see all these marks? Do we have a region where the marks kind of are concentrated, and we see that this is a region where the marks are concentrated, and that's nothing but the central tendency. But what is that one value? If I have to add up, we have to see the whole graph as a whole, as one piece, taking all the marks into consideration. What would be that one value which I can use to say, hey, that's the value where you can see that on an average, that's the value we get, where all the marks are either on the left or on the right or centered around that. So instead of the range, what is that value? And which is what is we are calling as mean in this example. And again, the same concept. We have to add up all the numerator and divide it by the total number of frequency. The only thing is, in this case, the numerator, the number of students we have clubbed. So we have to make sure that we don't forget that we have to multiply this, because that's the total number of students. For example, if you see here, one student got 100, second also got 100, and third also got 100. So the total, if you see one got 100, first student got 100, second student got 100, and third student got 100. So the total is, there are 3 students, 1, 2, and 3. 3 students got 300, right? So we have to make sure that we multiply that. So the total is 300, and hence we have to multiply these 2 elements. Let me rub this. Okay. So see, when the frequency is grouped, like how we have done here. So think of this as there are 3, instead of 3 entries, instead of 1 entry, we have got 3 individual entries like we have it here. So we have to multiply that. So we have to say 3 into 100 is equal to 300. 10 into 90 is equal to 900. Something like that. So 3 students have got 100 marks each. So total marks cumulatively for all the 3 students is 300. 10 students have got 90 marks each. So cumulatively all these things is 900, something of that sort. So the total marks, we will not simply add this, but we'll be adding this and this and this and this. That's the difference. Okay. So we will be basically multiplying by the frequency. So what we have done here, again, the formula is the same. Add up all the numerator, and then the total divide by the total number of students or the frequency in the denominator. Okay. And now let's see how we are going to add up. So if you see here, the one in the blue color over here highlighted. So the numerator is, we are going to sum up. We are going to take the number of students having the same marks and marks obtained. Like for example, I've showed here 3 into 100. I'm going to take that. And then I'm going to add up each one of them for this. Like I'm going to add up 300 plus 900 and stuff like that. That's what I'm going to do. And that's why I have put the sum here. And the notation becomes like this. The sigma x into f. I'm multiplying each row and adding it up, and they divide by the total number of students. And if you see here, I've put a detailed calculation on how it is done. So if you see here, 3 into 100, 3 students have got 100 marks. 10 students have got 90 marks. So I'm going to multiply those things, each row, and then I'm going to add up all of them. And that's what it is done. That is the numerator part of that. And the denominator, all I need to know is how many students. We know that we have got total 313 students. And if you add up this, we know that it will be 313. And if you see the calculation here, the numerator becomes 17925. The denominator is frequency 313. This is the numerator, and the average is 57.26. So again, the same thing. Instead of having a different variety of marks of each one is having a different marks. On an average, if someone is saying, hey, on an average, this class, what is the average mark on this subject? So the average mark is 57.268. And what it means is, if you see from this graph, this blue one, if you see all this blue one are the individual marks of the students. But if I'm talking about average, this orange bar over here, mean is equal to 57.268. What it means is, assume that all the 313 student, each one of these 313 student, if they would have scored 57.268, still we would have got the same total as over here, which is 17925. So it would have been the same thing. So whether we are going to take this marks which are individual, the actual marks, or we are going to assume that each student has got the average mark of 57.23, and if we add up that multiplied by for 313 students, it is going to give us the same answer. So that's what it means. So if someone wants to understand that I'm not interested in each student as a class, tell me what is the average marks, or what is the arithmetic mean, or what is the mean, or what is the measure of central tendency using mean, the answer is going to be 57.268. And that's what it means, and that's what this bar is. So if I have to just draw the average for the whole class, I'll be just using this bar and saying that, hey, this is where the class is, regardless of where the individual students marks lie. And if you see here, the marks are scattered around this. Some of them are more than this, some of them are less than this, some of them are near this. So on an average, the mean is 57.268. That's what it means. And with that, I'll try to wrap up this video, but just kind of tell you what the next topic in continuation is going to be. We spoke about a type 1 problem, ungrouped data. The next topic, we're going to talk about group data, and we'll discuss what is group data, and we'll take it from there on the next video. Okay, so I'll see you on the next video. Hopefully this was helpful.